Okay, so far for stoichiometry, we've just been doing our physical sciences revision. Today we're looking at excess and limiting reagents, which is new stoichiometry for chemistry. So the concept is that if you mix two reactants together, one of those reactants is generally in excess, and the amount of product that you can get is determined by the amount of the reactant that you have that's in limited supply. So it's limited by the amount of reactant that you have less of. So you might have a tiny amount of one reactant and a lot of the other reactant, but the maximum amount of product you can get basically depends on the tiny amount, if that makes sense. So let's have a look at this example. Silver chloride is insoluble when 3.74 grams of solid silver nitrate is dissolved in water mixed with 30 ml of 0.44 molar magnesium chloride, a silver chloride precipitate forms. So what mass of silver chloride precipitate is formed? So there's quite a lot to work out before we can answer that question. The first thing that we always do is to write a balanced equation so that we know the ratios. So we are mixing solid silver nitrate. That's being dissolved in water, so that'll be aqueous silver nitrate. And we're mixing that with magnesium chloride. So we've got silver nitrate in aqueous form plus magnesium chloride, which is also aqueous. And so we get, we know that we get silver chloride as a precipitate because it says. So we're going to get AgCl. That's a precipitate, so that's going to be a solid. So then what's left over must be magnesium nitrate. And balancing that equation, we're going to need two of those and two of those. So there is our balanced equation. Now we need to figure out how many moles we've got of each reactant so that we can find out which one we're limited by. Okay, so let's first calculate the number of moles of silver nitrate. So for silver nitrate, we are given the mass, okay, 3.74 grams. So let's do the mass divided by the molar mass. So 3.74 divided by the molar mass of silver nitrate. So silver is 107.9, nitrogen is 14.01, and then we've got 3 oxygens. Sorry, it's a little bit messy. And we get 0.0220 moles to 3 significant figures. Okay, now let's look at the other reactant. How many moles of that have I put in? So for the other reactant, magnesium chloride, they've given us the volume and the concentration. So I'm going to work that one out using N equals CV. So we've got 0.440 times 0.03, because of course we have to convert from milliliters to litres. And that gives me an answer of 0.0132 mole. Now we can't just choose the smaller number and say that's the limiting reagent, because we need to consider the ratios. Because if you look at the equation, it says that for this reaction to take place perfectly, we need twice as much silver nitrate as the amount of magnesium chloride that we have. So we need to take that into account. So let's think, okay, if I have 0.0220 moles of silver nitrate, how much magnesium chloride would I need to react with that? So let's have a look. Number of moles of magnesium chloride needed to react with the amount of silver nitrate that we have is going to be, so the amount of magnesium chloride is half as much, isn't it? Looking at the ratio. So it's going to be half of 0.0220, which of course is 0.0110 moles. So we would need that much magnesium chloride to react. How much magnesium chloride do we have? Well, we have 0.0132 moles. So we have more magnesium chloride than we need. Okay? Therefore, have more MgCl2 than required. That tells us that the magnesium chloride is in excess. Okay. If we've got an excess of magnesium chloride, then silver nitrate is our limiting reagent. Now you don't have to use all this wording when you do this yourself. I've just done it so that it's a little bit clearer where things are coming from. You would be fine just to calculate the number of moles of both and then to go straight ahead and say silver nitrate is the limiting reagent, if you've sort of done the rest in your head, whatever works better for you. Okay. All right, so that means that the amount of product that we can get depends on the amount of silver nitrate that we put in, okay, because we've put in more than enough magnesium chloride. We're not limiting. I'm going to run out of space here. That'll be fun. All right, so the question is, what is the question? What mass of silver chloride is formed? To find the mass of silver chloride, I of course need to first find the number of moles of silver chloride. So the number of moles of silver chloride, and we find that out by looking at the equation. So silver nitrate to silver chloride is a 1-to-1 ratio. So that means the number of moles of silver chloride is going to be the same as the number of moles of silver nitrate, which is, of course, 0.0220. Okay? Now, what mass of silver chloride is formed? So the mass of silver chloride is just going to be the number of moles times the molar mass. So the number of moles times the molar mass is 0.0220 times the molar mass. So we've got silver 107.9 plus chlorine 35.45. And if you put that in your calculator, you'll get 3.15 grams produced. Okay, the next question is, what amount of silver ion and chloride ion remain in solution after the reaction? So remembering that amount generally means number of moles, I want to find the number of moles of silver ions and the number of moles of chloride ions. Now, the original silver came from silver nitrate, okay? And that was the limiting reagent. That means that all of the silver nitrate got used up, okay? And it became a precipitate, didn't it? So all of the silver ions in solution were used to form our precipitate of silver chloride, which means that there are no ions left in solution, okay? So the number of moles of silver ions is 0 because silver ions is part of the limiting reagent. Okay. But what about the other one? Because we did have magnesium chloride in excess. Okay, so how much magnesium chloride do we have left? Let's have a look. So I'm going to consider all of magnesium chloride. So the amount remaining, we discovered that the amount of magnesium chloride that reacts with silver nitrate is this 0.0110 moles, didn't we? And we also know that we started off with 0.0132 moles. So the amount we've got left over is the difference. So starting with 0.0132, and the amount used in the reaction is 0.0110. So the amount left over is 0.00220 moles, apparently. Okay, so what about the number of moles then of chloride ions? Well, you'd think it would be the same, but not quite, because how many chloride ions are there in magnesium chloride? Well, there are 2. So you have twice as much chlorine ions as you have magnesium chloride. So the number of moles of chloride ions remaining is 2 lots of that, which is 0.00440 moles. And that's the limiting reagent question. For examples to try, I will upload those, some examples as a PDF.